Beautiful people, good morning.
Good morning, sir.
Okay, welcome everyone. I hope you are ready for the class. Today we'll be beginning the 5th module for the course. Remember, we are in chapter 5, or 5th module, discrete probability distribution. So this is what we are going to explore today. So please get ready with your note catcher there. We started probability in previous chapter, chapter 4. We work on the fundamental probability in chapter 4. Here in chapter 5, we'll be exploring the distribution, and it is called the probability distribution. First, we are going to look at the basic terms related to the probability distribution. The first one that we'll be talking here, or one of the very important terms that we'll be talking over and over again in this chapter, is the random variable. When we say random variable, it is a numerical value associated with each outcome of the probability distribution. That is, if any experiment is performed, and if we look at the output, and if we assign a numerical value to the output, that is called the random variable. For example, if I'm tossing 2 coins simultaneously, then what happens is I may get, if I want to count the number of heads, I may get no heads, or maybe I get 1 head and 1 tail, or I get both heads. So this number X representing 0, 1, and 2 in this case. So what I'm saying is, suppose you are tossing 2 coins and the number of heads can be, in both, you don't see any head, so 0. Or you'll see just 1 head and 1 tail, so 1 head there. Or you'll see both heads there. So this is the random variable. X equal to 0, 1, 2 is a random variable. So X is the number of heads. So here X represents number of heads while tossing 2 coins. So when you toss 2 coins, you may get no heads, or 1 head, or 2 head. So this numerical value associated here for this X, that X is the random variable. So we say a random variable is a numerical value associated with each outcome of the probability distribution. And when we talk about random variable, like the way we talk about variables in chapter 1, there are 2 types of random variable. One called the discrete random variable, and the other one is the continuous. So random variables, they are of 2 types: discrete random variable, and continuous random variable. So just like in chapter 1, when we say discrete variable, it does not take any decimal value. If the random variable does not take any decimal value, that is the discrete variable. But if the variable takes continuous value or decimal values, then it is called the continuous variable. For example, I have an example here. Number of calls made by college professor to his students in a day. So if we want to count how many phone calls are made by a college professor to his students in a day, that will be a whole number. It can be 1 or 2 or 3 or 4. It cannot be decimal. I make 2.5 calls. We don't say that. Okay. So it involves the whole number. That's why that is called the discrete variable. So number of calls made by college professor. If we want to find how many calls are made by college professor, maybe he made no calls, or maybe 1 call, or maybe 2 calls, or 3 calls, and so on. So you can see the random variable X, these are the numbers, or the numbers associated with the random variable X are the discrete values. They do not involve any decimal values. Okay, so those random variables which does not involve any decimal value, they are called the discrete variable. On the other hand, when we say the continuous variable, I have the example here again. Number of minutes spent by college professor while calling his students in a day. So how many minutes does the professor spend on the phone? Maybe with the first student, 2.3 minutes. That's possible. Decimal number of minutes, that's possible. Okay. Maybe 4.5 minutes, or maybe 1 minute. Okay. Or maybe 5.2 minutes. So you can see the decimal values are possible here. If the random variable can also be associated with the decimal values, then we say that the variable is continuous random variable. So here, when you're talking about the discrete and continuous variable, it is just like the discrete and continuous variable we have studied in chapter 1. When we say discrete, it does not take any decimal value. When we say continuous, it takes decimal value. So before we move on, are there any questions on discrete and continuous variable? Just say yes or no.
No.
No? Okay, awesome. So let's move forward to the probability distribution now. So based on each of these variables, based on the discrete random variable and continuous variable, we have probability distribution. In unit 5, in this unit, we'll be talking about the probability distribution based on the discrete variable called the discrete probability distribution. And in chapter 6, we'll be talking about the continuous probability distribution. So today our focus will be on discrete variable or discrete probability distribution. So when I say discrete probability distribution, it consists of value of random variable and their probability. So we have seen the random variables could be, for example, the discrete random variable while tossing 2 coins. And if we want to count the number of heads, we say that X can be 0, no head, or maybe there is 1 head, or maybe 2 heads. So that is the random variable. And if we find the probability of each, P of X, for example, probability of getting 0 head while tossing 2 coins, suppose it is 1/4. Okay. Probability of getting 1 head while tossing 2 coins, suppose that is 1/2. And probability of getting 2 heads, both heads, that is 1/4. So what I have done here is I listed the random variable X, 0, 1, 2, and their probabilities, 1/4, 1/2, 1/4. So this one is a probability distribution. Okay, if we have the random variable and their corresponding probabilities, then that is called the probability distribution. So always remember, when we are talking about the probability distribution, it consists of values of random variable X and their probabilities. But remember one thing, for this distribution that I've created here to be the probability distribution, it has to satisfy 2 conditions. That is, if you add all probabilities, it must be 1. The sum of all probabilities in a sample space must be 1. So here we have 1/4 plus 1/2 plus 1/4. If you add all this, it is equal to 1. 1/4 plus 1/2 is 3/4. 3/4 plus 1/4 is 1. So if you are adding all probabilities, and if the total probability is 1, that is one condition. The second condition is all the probabilities that you see here, the values of the probabilities must be between 0 and 1. You have seen that in chapter 4 also. When you're calculating the probability, probability is a number between 0 and 1. So all the values must be between 0 and 1. And you can see that all these values, 1/4, 1/2, 1/4, these are the numbers less than 1, but more than 0. So that means this is a true probability distribution. So this is the probability distribution of number of heads while tossing 2 coins. Here I have the other one. We can check it quickly. For example, the probability distribution for the number of heads on tossing 3 coins. Now we are tossing 3 coins simultaneously. You may get 0 head, no head, or 1 head, 2 heads, or 3 heads. And we have the corresponding probabilities here. So we have created a distribution for the number of heads while tossing 3 coins. Now, if you want to check whether this is a probability distribution or not, again, you have to check those two things. If you try to add all these, it should be 1. You can see 1/8, 3/8, 3/8, and 1/8. All of them have a common denominator of 8. Now, if you add the numerator, 1 plus 3 is a 4, 4 plus 3 is a 7, 7 plus 1 is 8, 8 over 8 is 1. So it satisfies the first condition. Sum of all probabilities is 1. And if you look at the values of the probabilities is 1/8, 3/8, 3/8, and 1/8. If you try to change it to decimal, you will see that all these values are between 0 and 1 again. So since all these values are between 0 and 1, and when you add all probabilities, it is equal to 1, that means we say that this is also an example of probability distribution. The first one is the probability distribution while tossing 2 coins, and this one is the probability distribution for number of hits while tossing 3 coins. So remember here, when we say discrete probability distribution, it is, or the discrete probability distribution is a distribution where we have the random variable x and their corresponding probabilities. And for this distribution to be probability distribution, it has to satisfy 2 different conditions. First, if you add all probabilities, it must be 1. Second, if you look at the values of probabilities, all probabilities must be between 0 and 1. If these 2 conditions are true, then it is a probability distribution. Otherwise, it is not a probability distribution. When we start working on the example, we are going to learn how to create the probability distribution, and also we are going to learn how to verify whether it is a probability distribution or not. Before I move on to those examples, do you have any question on probability distribution and how we check whether it's a probability distribution or not? Any questions?
No.
Awesome, that's good. Okay, let's take an example now. Suppose X is the number of hits while tossing 2 coins, the same example that I was talking before. Okay, X is the number of hits while tossing 2 coins. Construct a probability distribution for the random variable X and represent it graphically. So we are asked to make this probability distribution. I wrote it here, but how we come up with these probabilities? How we come up with the probabilities like 1/4, 1/2, 1/4, and the number of hits at 0, 1, 2. Let's find this out. So here we are asked to do that. We are actually asked to construct that. So X is the number of hits while tossing 2 coins. So we are tossing 2 coins, and we already know how to make the sample space for that from the previous chapter. So if you're tossing 2 coins, what do we get on the first toss, or from the first coin, is we'll get a head or we'll get a tail. So that's what we get from the first. Similarly, from the second, you'll also get a head or you'll get a tail. So if we want to write the sample space completely, then we can fill this table. Okay, if we want to write the probability distribution or sample space for this, we can complete this table. So if you look at the first one here, you will have head on the first and head on the second. So head and head, head on the first and tail on the second, head, tail, tail on the first and head on the second, tail, head, and then tail on the first and tail on the second, tail, tail. Now what we are looking for is X is the number of heads. So in this sample space, if you want to count how many heads are there, then what you can see is here in the first one, there are 2 heads. 2 heads. In the second, there is 1 head. Here we also have 1 head. And here we have no head. 0. So that means if we look at the number of heads can be 0, it can be 1, or it can be 2. So your random variable X is 0, 1, or 2. Okay, that is your random variable. Now we need the corresponding probabilities to make it a probability distribution. So let me draw this table first and then write down the probabilities. Okay, now, if we want to look at the probabilities of each, you can see that there are 4 possibilities, or 4 in the sample space. So total is 4. And if we want to see how many times we get 0 hits, there is only one place where we get 0 hit. So 1 out of 4. Probability is 1 out of 4. Similarly, if you want to see how many times we get 1 hit, we get 1 hit here and 1 hit here. We get 1 hit 2 times. So it is 2 divided by 4, 2 over 4, or that is half, right? 2 divided by 4, when you reduce it, that's a half. And then here, if you want to see how many 2 hits are there, or both hits, there is only one case where we get both hits, 1 out of 4. 1 out of 4. So this is how we can create the probability distribution. So that's the first part here. Construct a probability distribution for the random variable x. And if you look at the probability distribution here, this is exactly the same probability distribution that I was writing before. This one here. This is the probability distribution for the number of hits while tossing 2 coins. So this is how we can create that. Now, before I move on to graphing this probability distribution, do you have any question on how I constructed the probability distribution?
No.
Okay, awesome. So we constructed the probability distribution here. Now what we are asked to do is we are asked to draw it graphically. When you draw the graph for the probability distribution, what you do is we have the x values, or the random variable, along the x-axis and probabilities along the y-axis. So we have to draw the horizontal axis for the random variable x, like that. That is for the random variable x. Your x will be along the x-axis, the random variable, and you'll have the probabilities along the y-axis. You will have the probabilities along x-axis, like that. Now, you know that the total probability will be 1, so maximum we can go up to is 1. So maximum we can go along the y-axis is 1. So if I divide it into the middle, into 2 parts, that is a half. That's a half. So if I divide further, that will be, this will be 1/4 and that will be 3/4. Okay, 1/4, 1/2, 3/4, and then 1. So I'm just counting by half over here. From here to here, it's half. And then when you move half, it will be 1. And if I divide it in the middle, that will be quarters. Okay, that is the probabilities along the y-axis. Now, if you look at the random variable, we have the random variable 0, 1, and 2. And you are going to put those values along the x-axis, 0, 1, and 2. So you can start anywhere. So I'm going to put 0 here, and then 1 here, then 2 there. 0, 1, 2. Then after that, once we have that, we need to draw the graph. And when you draw the graph, your graph is like a histogram. It's not a histogram, it's a probability distribution graph. But what I'm trying to say is you have to draw the bar for each probability, and the bars must be connected. So here for 0, the probability is 1/4. So around that 0, you'll draw a vertical bar of height 1/4. You'll draw a vertical bar of height 1/4, just like that. So height is 1/4, because the probability of getting 0 is 1/4. That is the meaning of that. Similarly, you have to draw the second one here for 1, and then the probability is 1/2. So when you draw the second bar, the height must be 1/2. Let me fix it a little bit. Okay. Like that. Little bit wider. Okay, there we go. So this is 1/2. And finally, the third one should have a height of 1/4. Okay, let's draw the third one with the height of 1/4 again. There we go. So that has a height of 1/4. So although this graph looks like a histogram because the bars are connected, this is not a histogram. This graph is the probability distribution graph. So the graph that I have drawn here, you can write the name for this. This is the probability distribution graph. Let me write the name here. Probability distribution, sometimes written as PD graph. Okay, so we can represent the discrete probability distribution using a graph that looks like a histogram. Although it looks like a histogram, this is not a histogram. It just represents the random variable along the x-axis and probabilities along the y-axis. So this is the basic idea about the probability distribution.
I have a question.
Yes.
For the X, the probability of getting one heads in the chart, yeah, how is it 1/2?
Because you have, how many heads are here? That's one possibility here, one possibility here. There are two possibilities, right?
Yes.
So two possibilities out of 4, 2 divided by 4. Okay.
Oh, so you
reduce it, yeah.
Oh, okay, right.
And
Thank
when you reduce that, it's 1/2, right?
Yeah.
Okay, good. Okay, any other question on this example before I move on to next one? Okay, look like there is no question. Let's move on to the next one. So in the first example, we learned how to create the probability distribution. Now in this one, we need to check whether this is a probability distribution or not. See, determine whether each of the following distribution are probability distribution. So if we look at the first one, you know that in order to check whether it's a probability distribution or not, or sum of all probabilities must be 1 and all probabilities must be between 0 and 1. So if you look here and try to find the sum of all probabilities, see, we have the random variable x and the probabilities here. Now, if you try to add this 0.1 plus 0.2 plus 0.1 plus 0.4 plus 0.3, it is 1.1. Okay, it is 1.1. It's not 1. Okay, this is not equal to 1, not equal to 1. So the first condition is not true, because for the distribution to be probability distribution, it has to satisfy both conditions. Here, when you try to add all probabilities, it is not 1. So is this a probability distribution?
No.
No, this is not a probability distribution. Okay, this is not a probability distribution. Okay, the first one is not a probability distribution. Now let's check the second one. So we are going to do the same thing. First, we are going to check the sum. So here, if you try to add all probabilities, you can even add using your calculator if you want. 1/4 plus 1/2 plus 1/8 plus 1/8. That is equal to 1. Okay. If you add all these probabilities, it is equal to 1. So first condition is true. Second, we have to check whether all probabilities are between 0 and 1 or not. So if you look here, all these probabilities, 1/4, 1/2, 1/8, 1/8, all these values are between 0 and 1. Also, all P of X, all probabilities are between 0 and 1. Okay, sum of all probabilities is 1, and all these probabilities are between 0 and 1. So is this a probability distribution?
Yes.
Yes. Okay, good. Yes. This is a probability distribution. I hope that is not very difficult. We are just checking whether it is a probability distribution or not. Any question there?
No.
Okay, awesome. Now let's move on to next example. Still looking at the basic definition of probability distribution. Okay, fill in P of X equal to X, that is probability of X given here. So probability distribution table is given here, but there are two missing values there. Okay, so you have to fill in that table to give a legitimate probability distribution for the discrete variable X, whose values are 1, 2, 3, 4, 5, 6. Okay, so what we know is for this distribution to be probability distribution, sum of all probabilities must be 1. But all values are not given. But tell me, if we add the last 3 probabilities here, if we add these 3, what will be the total? You can add using your calculator. 0.14 plus 0.25 plus 0.20. What is the total?
0.59.
0.59. Okay. That means to make a total of 1, what should be the sum of the missing 2? 0.59 plus how much will be 1?
1 minus 0.59.
Exactly, 1 minus 0.59, because out of 1, 0.59 is already here. So if we do 1 minus 0.59, it will give you the sum of these two. So what is 1 minus 0.59?
0.41.
0.41. Awesome, beautiful people. Okay, 0.41. That means when you find these two values, the sum must be 0.41, and it must be a value between 0 and 1. So you can have any values, you can select your own values, but the sum must be 0.41. So what I'm saying is, if I do this, for example, if I say 0.20 and 0.21, that is 0.41, right? 0.20 and 0.21, that is 0.41. So that is one possibility. You can do this. That's your answer. Or maybe the other student have done this. Say, for example, 0.30 and 0.11. If you add 0.30 and 0.11, it is also 0.41. So you can select any number whose sum is 0.41. Does that make sense?
Yes.
Okay, so I'm just going to leave here 0.30 and 0.11. You can have any other number. You may have 0.40 and 0.01, 40 and 141, right? So it's up to you how you want to select it, but the sum must be 0.41. So it's not a difficult one. All you have to do is you must try to look for those two numbers so that when you add everything, it is equal to 1. Okay. So up to here, we are looking at the basic idea about the probability distribution. Now we are going to move on to the second part of the chapter for the discrete probability distribution. And here, once we have the probability distribution, we'll be able to find the mean and the standard deviation. Okay. But the mean and the standard deviation that we are talking here is a little bit different. We are talking about the mean and the standard deviation of the probability distribution. Remember one thing, the mean, let me highlight here or underline, the mean and the expectation, the two terms here, mean and the expectation, they are the same thing. Although they have a different name here, they are the same thing. If we talk about mean, we represent it by mu. And if we talk about the expected value of the probability distribution, we write EX. But both of them technically represents the same thing. That's why the formula for mean, you can see, formula for mean is the sum of X times P of X. We are adding X and P of X. Okay, the sum of a product of X times P of X is added. So it is sum of X times P of X. Similarly, for the expected value, you will see the same thing. Expected value is the sum of x times p of x. That's why, although they look different, they are exactly the same thing. Okay, so make sure you highlight this formula because you'll be using this formula over and over again. And the other one is the variance and the standard deviation. You know that if the standard deviation is known, to find the variance, we square it. So here you have the formula for the standard deviation. Standard deviation is the square root of the sum of x minus mean squared times p of x. That will give you the standard deviation. That means if you want to find the variance, you square it. So square is, when you square up the right hand side here, the square root will go away and you'll have the sum of x minus mean squared times p of x. So in next two examples, we are going to learn how to find the mean and the variance or standard deviation and calculate the expected value. So if you just look at the formula, it doesn't make a lot of sense. But when we try to apply it, this will make more sense. So please highlight the formulas here and get ready for the example. Okay, ready for the example?
Yes.
Okay, good. Here is our example. So let x be a random variable with the following probability distribution. Find the expectation EX and the variance of R. So two things are variance of X. So two things are asked here. The first one is expectation. So you know that from the previous slide, expectation. Expectation is calculated using the formula sum of x times p of x. Okay, we know that. Similarly, the second thing that we need to find here is the variance of the random variable x, and it is the square of the standard deviation. So we can write variance. Here they have denoted as variance of x, var x is the square root of, you have seen from the previous slide, it is the sum of x minus mean squared times p of x. Sum of x minus mean squared times p of x. So we'll be using this formula to solve the problem. So let's begin by making the table. First, we are going to write the given values, the random variable x and the probability. So you'll write the random variable x. These are 10, 20, 30, and 40. The corresponding probabilities are 0.05, 0.7, 0.15, and 0.1. Those are your values, x and p of x. Later on, we'll do the total. So I'm just going to do that. I'm not going to add all these p of x. If you add all those p of x, you know that it'll be 1. Okay. Now, to find the expectation, look at the screen. To find the expectation, expectation is sum of x times p of x. So in next column, I need this product, x times p of x, and then I need to add them together. Okay, I want to find x times p of x, and then add them together. So here, you can also multiply along with me in your calculator if you want. 10 times 0.05 is 0.5. Let me use different color for that. Okay, 0.5. 20 times 0.7 is 14. 30 times 0.15 is 4.5. And 40 times 0.1 is a 4. And if you try to add all these, 0.5 plus 14 plus 4.5 plus 4, that is a 23. That is 23. So that means the value of the expectation, this formula here, expectation, let me write here. Expectation denoted by E of X, calculated using this formula, sum of X times P of X. So if we find this sum, we got 23. So sum of X times P of X is 23. That means the mean of the probability distribution or the expectation value of the probability distribution is 23. Remember, the formula to calculate the mean of the regular data and formula to find the mean of the probability distribution is different, because these are not the same thing. We are not calculating the mean of the regular data. Here we are calculating the mean of the probability distribution. So mean of the probability distribution, also called expectation, is the sum of X times P of X, is 23 in this case. So that is the first part. We are able to find the expectation. Before I move on to variance, do you have any question on how I calculated the expectation or expected value? Is this clear so far?
Yes.
Okay, that is good. That is good. If that is clear, that is awesome. Okay, now we are going to calculate the variance. You can see in variance, we have to find the sum of something that looks like this. Look like a little crazy there. It's not that crazy though. We have to find the sum of, we have to find the sum of, okay, hold on one thing. For the variance, we don't need this square root, right? Variance is without a square root. Sorry about that. If it is a standard deviation, there will be square root, but variance is just like that. Variance does not have the square root. It is the sum of that. So I need X minus mean squared. Let me write that. X minus the mean or the expected value is 23. X minus 23 squared times P of X. I have to find this and then add them together. Okay, so for the first line here, the value of X is 10. So it will be 10 minus 23 squared multiplied to P of X. Your probability is, for the first row, the probability is 0.05. 0.05. And if we type this in our calculator and simplify, when you are typing it in your calculator, make sure you type starting with the parenthesis, 10 minus 23, parenthesis closed, squared, and then times 0.05, you should get 8.45. Make sure you check it. You should get 8.45. Similarly, if I go to the second row, the value of X is 20. 20 minus 23 squared times the probability is 0.7. And if we simplify this using calculator, it is 6.3. For the third row, the value of X is 30. 30 minus 23 squared times the probability is 0.15. And if you simplify this using calculator, you should get 7.35. Make sure you check it. And for the last one, your X is 40 minus 23 squared times the probability for this one is 0.1. In this case, if you simplify using calculator, it will be 28.9. So this is how we find the values of X minus mean squared times P of X for each of the random variables given here. For each row, you have to find this. And in the formula, there is a sum. So we need to add all these: 8.45 plus 6.3 plus 7.35 plus 28.9. If you add all that, check it what you'll get. How much did you get? 8.45 plus 6.3 plus 7.35 plus 28.9. 51. Exactly, it's 51. Very good. So we get 51. That means your variance in this case, which is given by this formula here. Let me write down again. Variance, you can write VARX, or this is also the square of the standard deviation, is equal to, it is the sum of, we have seen it is the sum of x minus mean squared times P of x. And if we add all that, we'll get a 51. So in this case, the variance is 51. If you are asked to find the standard deviation, then you'll take the square root of this. Okay, if it was asked. This is not asked here, but if you are asked to find this standard deviation, you'll take square root of this one and you'll get 7 point something. Before I move on to next example, is this example clear to everyone in the class?
Yes.
Okay, that is awesome. Now here is the other example, or last example from discrete probability distribution, or last example for today. Okay, in next class we are going to look at one special type of discrete probability distribution called binomial distribution. But for today, this is going to be the last example on the discrete probability distribution. Okay, the question here is, at a raffle, 1,000 tickets are sold at $3 each for 4 prizes: $500, $300, $200, and $100. That means in total, 1,000 tickets were sold. Cost of one ticket is $3. That means 1,000 tickets are sold for $3 each. Okay. And they are giving out 4 prizes only. The first prize is $500. One person will get $500. The other person will get $300. The third person will get $200. And fourth person will get $100 done. Okay. Now the question is, what is the expected gain if you buy one ticket? So what you are doing is you bought one ticket and you are looking for the gain. You want to gain something from this. So let's see if that is possible. So here you can see that the random variable x is the gain. So gain is the x. Now, as we work on this, try to help me. If somebody got $500 gift or $500 prize, what is the gain? Somebody bought a ticket for $3. Okay, listen to this very carefully. Somebody bought one ticket for $3 and they got $500 prize. What is the gain?
$497.
$497, because it is 500. They are getting $500, but they have spent $3. So 500 minus 3, that will be $497. Very good. $497. So one person who get $500 prize will actually gain $497. What will be the gain for this second person who got $300? If you get a
297.
297, very good, 297. Similarly, if we get $200, what is the gain?
197.
197. If you get $100, what is the gain?
$97.
$97. Very good. And then if you don't get anything, what is the gain?
It's a loss.
It's a loss, negative $3 loss, right?
Correct.
You're losing that negative $3. Okay, you're right. So this is what happened. So 4 people will gain. How many people will lose? 4 people will gain something. How many of them will lose?
996.
996. That's right. Because tickets are sold to 1,000, right? 1,000 tickets are sold. Okay, this is the gain. Now, if you want to find the probability of gaining, probability will be, okay, let me do this a little bit just to make it a little beautiful. Okay, total. I don't need to add P of X. If I add, it will be 1. Now, probability will be only one person will get this $500 prize. So it will be 1 out of 1,000. Only one person will gain this $300. So the probability will be 1 out of 1,000 again. Similarly, the next one is only one person will get 1 out of 1,000. Next one also, only one person will get 1 out of 1,000. And the last one is 996 out of 1,000. Right? 996 out of 1,000. You can write the probabilities like this, or this one, 1 over 1,000, you can write that as 1 divided by 1,000 is 0.001. You can also write like that. Okay. So this one will also be 0.001. This one will also be 0.001. Because normally we write probability as a number between 0 and 1. That's why I'm changing it to decimal. And the last one, 996 divided by 1,000 is 0.996. Let me write that, 0.996. I hope how I change those. I hope you understand how I change this fraction to decimal. When you divide and change it to decimal, these are the values. Now the question is, what is the expected value of gain? Here, gain is the variable, and we are looking for the expected value. So you know that the expected gain, let me write here, expected gain, we write it as E of X as the expectation, is the sum of X times P of X. Okay, expectation will be sum of X times P of X. Here is X, here is P of X. So we have to multiply them and add them together. So next what we need here is X times P of X. X times P of X. So now we can multiply them in the calculator. So you can also multiply using your calculator along with me here. So if you multiply the first one, 497 times 0.01 is 0.9, right? Make sure you check it, 0.497. 0.01 times 297 is 0.297. Similarly, the next one will be 0.197. Next will be 0.097. All values are positive so far, but the last one has a -3. So -3 times 0.996, that will be a negative 2.988. Make sure you check it. Negative, because one of them is negative, and 3 times 0.996 is 2.988. Now the expectation is you add all those. Now if you add all these values, okay, if you add all these values, 0.497 plus 0.297, use your calculator and add it, 0.197 plus 0.097, and then the last one is minus 2.988. What did you get? I want all of you to add. The last one is minus, by the way. 0.497 plus 297 plus 197 plus 097, then minus 2.988. What did you get? Waiting for your sum there. Anybody got the sum?
I got negative 1.9.
That is right. So negative 1.9. So meaning of that is when you're adding all this, that's the expected value, you are getting negative $1.9. So that means if you just buy one ticket in general or on average, there is a loss of $1.9. That is the meaning of that. Okay. In general, there is a loss. So that means if you just buy one ticket out of 1,000, there is no chance of gaining. There are less chance of gaining, but more chance of losing. That is the meaning of that. So this is the real world application of the discrete probability distribution that we explored today. Is this example clear to everybody in the class?